How massive wind turbines are constructed. Massive turbines are massive machines that are used to convert the energy of flowing water, wind, or steam into mechanical energy that can be used to generate electricity. These turbines are incredibly complex structures that require a great deal of engineering and fabrication expertise to construct. Today, we will talk about how massive wind turbines are constructed. But before starting the video, be sure to smash the like button and subscribe our channel to never miss out any of our videos. We usually only see a wind turbine's final erected look when passing through them near highways, countrysides, or on rare occasions on the shorelines. Despite their vast size, wind turbines seem relatively straightforward and fairly uncomplicated. However, there is a long, tedious process behind constructing a wind turbine, including the challenges of handling huge complex parts such as the rotor blades. A wind turbine consists of three essential parts: the tower, the nacelle, and the rotor blades. The tower structured as a steel lattice tower similar to electrical towers, or sometimes as a steel tube-shaped tower with an inside ladder to the nacelle. At the same time, the rotor blades are connected to the nacelle. The wind turbine's electrical equipment consists of an electrical grid infeed system and a range of sensors. Wind direction, temperature, and wind speed sensors are found around the nacelle, allowing turbine monitoring and control. Wind turbines include other additional heating, cooling, wind direction, lifting equipment, and fire extinguishing equipment components. Before any consideration can be made, the construction of individual wind turbines from the manufacturers must decide the appropriate area for installing wind farms. That means that the winds must be reliable. Their speed must be more than 15.5 miles per hour daily, 25 kilometers per hour, supposing that the winds are heavier during those seasons. Another consideration that needs to be prepared for is the rise of temperature from heat, where heating increases electrical power consumption. Wind farms operate best in open areas with gently rolling lands surrounded by mountains. These areas are chosen because wind turbines can be installed on ridges and remain unobstructed by trees and buildings. Mountains concentrate the airflow, producing a natural wind tunnel with stronger, faster winds. Wind turbines must also be situated along grid lines to allow the local power plant's energy flow. Additionally, because wind turbines have many environmental advantages, we usually assume that having them sitting on a wind farm would not be an issue. Unfortunately, this is not the case. With every electrical power plant project, the proposed wind project must undergo a site review process to obtain permits and approvals before construction and operation. Eventually, when a wind turbine is built, the roads are cut to make way for parts to be transported. At each location of the wind turbine, the land is graded and the pad area leveled. A concrete base is then placed on the site, preceded by the installation of underground cables. These cables link the wind turbines in series and connect them to the remote control center where the wind farm is controlled. The energy is sent to the power company. The first step in the construction of the wind turbine is the construction of the tower. The components are bolted together before being erected, and the tower is held horizontal before being mounted. The tower is raised by a crane, all bolts are tightened or adjusted, and stability is tested upon completion. Next, the fiberglass nacelle is installed with its inner workings from the main drive shaft, gearbox, and blade pitch and yaw controls. It is assembled and mounted on the base frame of the factory. The nacelle is then locked around the equipment. The nacelle is elevated to the completed tower and bolted into place. Once the design and planning stages are complete, the next step is to fabricate the components of the turbine. This typically involves casting the rotor, the generator, and the casing in a foundry, as well as machining and assembling the various components. During this stage, the components are also tested to ensure that they meet the required specifications. The gearbox, main drive shaft, yaw controls, and blade pitch are assembled and mounted on the factory base frame. The nacelle is screwed and the machinery is enclosed. At the location, the nacelle is raised and attached to the completed tower. Usually, the nacelle is made up of fiberglass and would include the main drive shaft and the gearbox. Wind turbines are a common feature of the UK landscape. According to a recent government report in 2019, wind generators became the UK's second-largest source of electricity, providing 64 terawatt-hour. This was almost one-fifth of the UK's total generation, achieved by record onshore and offshore generation despite suboptimal conditions for wind, with 2019 seeing the lowest average wind speeds since 2012. Perhaps the longest part of the process is that of planning. A site survey needs to be carried out to monitor local wind speeds over a period of time, usually at least 3 months. As a guideline, for a wind turbine to be economically viable, there needs to be an average wind speed of at least 5 meters per second and in an area with minimal turbulence from surrounding trees or buildings. Planning permission may need to be granted, depending on the geographic location and usage. If in doubt, the local planning officer should be notified before any construction is started. It is good practice to discuss plans with neighbors to avoid any ill will or indeed planning objections. Mortgage and insurance providers may need to be notified too. Once the foundations have been securely laid, it's time to start erecting the wind turbine assembly. The exact process depends on the scale of the turbine. However, the order is similar in most cases. Weather, in particular wind strength, plays an important part in selecting the exact dates to erect the turbine. The mast is erected using a crane, either as a single unit or in multiple parts. Once secured, the nacelle containing the generator is hoisted on top of the mast and secured in place. Finally, the turbine blades themselves are lifted and attached to the generator. For smaller turbines, the complete assembly can be built horizontally and then carefully raised into place. Once the mechanical components have been assembled and tested, an electrical engineer can combine them with the previously laid wiring and electronic systems. Connection of the completed system to the grid happens in conjunction with your local district network operator. Final electrical safety and performance checks are carried out and documentation, such as maintenance manuals, warranties, and registration details are provided. The turbine is ready to generate green electricity. Just add wind. Wind turbines usually undergo routine checkups and maintenance to reduce failures. Typically, there is an inspection every few months. Ideally, every 3 months, and maintenance checks are required every 6 months. Any moving component would be lubricated and the oil level in the gearbox is checked. Massive turbines are complex and challenging structures to construct, but they play a critical role in the generation of electricity. From the design and planning stages to the fabrication and installation of the components, the construction process requires a high level of expertise and a great deal of attention to detail. By following these steps, it is possible to construct a massive turbine that is safe, efficient, and capable of generating power for years to come. Hope you enjoyed our video. Let us know your thoughts in the comments section below. If you liked our video, then hit the subscribe button to never miss out on any of our videos. See you next time.